I said, today we're going to actually be graphing functions that are continuous. And when they are continuous functions, we're going to talk about them, the ones we're going to do. The domain is going to be all real numbers. So how do you feel about having to use the whole number line for x in your table? How do you feel about having to use the whole number line, because that's what all real numbers means. It says graphing functions with the domain of all real numbers, so the whole number line.
I'm going to put a little r.
I know, but we have to graph. So we're just going to put an r on our table and we're going to say,
Yes.
we're going to get one y value for that r?
Yes.
How's that going to happen?
I don't know.
So x can be negative 1 million, x can be 0, x can be 500, x can be 2 billion. It can be whatever you want it to be when the domain is all real numbers.
No, we wouldn't put r in the graph. We would just put a straight line and continue with the dots.
We are going to, with this today, we are going to connect the dots. We're going to have some dots to connect, don't we? They have to come from somewhere.
We just
So-
got to put the points into the line where the line needs to go.
We need to choose some x values, both some negative and positive, and evaluate for y. Or in other words, we say we can't even begin to do the whole number line. So we need to pick some of our own x values. We need to choose some numbers from the number line, put them into the function, and get our y values. Do the same thing we did yesterday. Write as ordered pairs, graph, but the difference is today we are going to draw a line or a smooth curve, depending on how those points kind of line up. We're going to draw a continuous graph today. Trey,
Do we have to pick x values that will make a straight line?
I'm going to help you with that. Okay? So if it is a linear function, which we learn in the next chapter, if it is a linear function, it does not matter which x values you pick, you would get a line. But we have to pick some so that we have some points to put on the graph to see our line. Isaac,
Why do they have to be straight?
why do they have to be what?
Straight.
They don't have to be straight. Some are and some are not. So we'll find out which ones are going to be, and maybe and which ones aren't going to be. So let's look at our first one here. Y plus 2 equals 3x. Is that what we call in function rule form? Is the function rule on one side and the y by itself on the other side? No. So what we want to do first of all today is if they're not in what we call function rule form, we're going to put them there. We're going to get the y alone. So what should be our first move here?
Subtract 2.
We need to get the y alone by subtracting 2 from both sides. So go ahead and do this with me. Subtract 2 from both sides. Now we have y by itself on the left side, and we have 3x take away 2. Can we put those together? Are they like terms? No. So what is our function rule then? Rose?
3x minus 2.
Yeah, so we're going to move that 3x minus 2 down to our table to be the part. And don't draw any vertical lines yet. Don't finish your table yet, because we don't know how much work it's going to take us. Okay, so I'm going to tell you that today, the functions that you're going to work with, it's going to be they're going to be friendly with these x values. We're going to use, I'm going to pick them for you. We're going to use negative 2, negative 1, 0, 1, and 2. Because I know those will fit nicely on the graphs that I'm going to provide for you. Okay? Because even though the coordinate plane I give you is a certain size, it really does go on forever and ever and ever. Okay, so let's do our substitution step now. So we have negative 2 that's going to go in for x. Don't get ahead of me here. Some of you are not doing this properly. You're going straight maybe to your calculator and letting it do all the thinking. What do we do first in this 3 times negative 2 minus 2? What would be our first thing that we would do? Trey?
Get rid of the parentheses.
Get rid of the parentheses. How do we get rid of the parentheses? By multiplying. So we're going to take 3 times negative 2. So we're going to say, oh, that's negative 6. Take away 2. And now we say, okay, I think I'm ready to say this is how much room I need. I can put my y value over here. What is my y value?
Negative 8.
Negative 8. And then there were some of us that stopped here and went right to putting it on the graph. But what do we do first?
Right on hold.
It's right up here.
Right as ordered.
right as ordered pairs. Every point on a graph has an ordered pair name. So -2 to -8. Okay, let's get all our ordered pairs first and then we'll go graph. So now we're substituting in the rest of our x values. So I think you're capable of filling out the rest of this table, right? Go ahead and do your work getting your y values, setting up your ordered pairs. When you're done, before we graph them, let's make sure, because you notice I made a couple of mistakes on the answer key today, so let's make sure that we all agree. Anybody need to challenge me on any of mine? And Cameron?
I noticed a pattern in the lines,
Oh, you noticed a pattern in the y's. What's happening?
adding 3.
The y's are going up by 3, okay? Now, if there is a pattern in the y's, that means there's also a pattern in the
X.
x's. What's the pattern in the x's?
It's +1.
It's going up by 1. So if you have a pattern going on in the x's, and you start to see a pattern develop in the y's, you can say, oh, I think I know what the next one's going to be. But again, we're going to show the work until we're really good at this, okay? So I'm not making you make extensive tables, because remember, this table could be how big? Really, really big. It's going to be all the real numbers. We could never even actually make the whole table. So we're only doing 5 points. Okay, let's go get our points put on our graph then, because I don't think anybody sounds like they're going to challenge me on any of them. What do you notice about the graph?
It's straight with the line. It's
Okay, take your ruler and line them up through your points and see if it is a straight line, is it?
Yes.
Because we don't just assume it is, and we don't make it look like it. Because if it had to be a jagged one, if you had to use your ruler for part of it, then you had to give your ruler a turn to do the rest of it, then it's not a line. Then we would do a smooth curve. But if this is an actual line that we can put through them, then we're going to draw a line through it. So now we would, because again, we're doing a continuous graph today. We got to pick the x values, and we're going to put arrows at both ends
and then problem solved.
to show that it really has lots more territory it covers. How many ordered pairs does this line have?
Any number.
How many?
Infinite.
An infinite number of them, but we used how many just to get the graph? We
5.
used 5. We used 5, but that doesn't mean those are the only 5 points on this line. They're not the only 5 ordered pairs for this function because it's a continuous function where we got to pick some x values. Okay, so let's put that here, that we have a continuous graph. And the reason is because the domains was all real numbers, that's why. It was because the domain was all real numbers. Even though we see some actual x values in our table, it's because I picked those for you. Or if I said to you, you get to pick your own, you would put what you want in the table. Rose?
Okay, so later in the lesson, when we're gonna have to do discrete and continuous groups together, how would you find, like, you know,
How would you be able to determine between the two? Yeah, that's a good question. How would you be able to tell? What if now when the quiz comes up, they're all combined in one thing and you're like, okay, well, how do I know if I'm supposed to connect the dots or not? Or, so is this a discrete graph or is this a continuous? Anybody think they know the answer to Rose's question? What do you think, Isaac?
If it's discrete, you would have to find out the points, or what they tell you.
Okay, so they would tell us what?
They would tell us the points, and you have to figure out the y's.
Yeah, they would tell us the actual x values they want, and here's how they would, okay? They would take, remember how yesterday they gave us a domain in set notation like this? Remember this?
Yes.
And maybe they had -2, -1, 0, and 1, just like that. That is saying only these four because it's written in set notation like this. So they gave it to us like this. If they say to us the domain is all real numbers, they're saying, how are you going to get all the distinct points for that? Can you? No, you can't even begin to. So you got to graph this as a continuous, and you get to pick your own. That's why they don't specify them like this. So that's a really good question. Any others? Any other concerns? Okay, let's go to the back side, see what happens back here then. So again, today our domain is always all real numbers. Okay, our domain today, we should have all continuous graphs today. We're practicing those kind. It's all real numbers. Okay, so is this in what we call function rule form?
Yes.
F of x equals the absolute value of x minus 1. Is that in function rule form?
Yes.
Yeah, it really actually is. Remember, this can be rewritten as y equals the absolute value of x take away 1. So what's our function rule?
X minus 1.
absolute?
Absolute value of x minus 1. And we're going to go with the same x values we chose last time. Okay, so let's put those in our table. We're going to go with the same 5 that we did last time, because I know that will give us a good graph for this one. And now we'll do our substitution step. Absolute value of -2 take away 1. Also known as add the opposite, -2 plus -1, right? So we now have our absolute value bars aren't gone yet. We have some simplifying to do inside them. Don't get in a hurry. What's -2 plus -1? -3. So we now have the absolute value of -3. Now we can get rid of the absolute value bars. We can say the absolute value of -3 will give us our y value. So what is our y value?
3.
+3. So we have ordered pair,
-2, 3.
-2, 3. Okay, so you don't get to just do this step, the first one right here, and then go to the y value. You do the working your way to the y value. So now we're going to substitute negative. You know what? Let's just change this right away to x plus the opposite of 1, which is x plus a -1. It's going to go a lot better for us. So we're going to have -2. That's what. Oh, wrong thing. What am I doing? How about -1? We're going to put in our x value. And then we have plus a -1.
-2.
So we now have the absolute value of -2. And what is the absolute value of -2?
Positive.
+2. How far is it from 0? It's 2 units away from 0. So we have ordered pair, -1, 2. Okay, let's do a 0. Absolute value of 0 goes in for x. Add that -1. So what's inside our absolute value bar simplify to? Absolute value of what?
1.
-1. 0 plus -1, isn't that -1?
Yes.
Okay, and what is the absolute value of -1?
Positive.
+1. Now, I love that you found the pattern last time. Do you think there's a pattern going on this time?
Yeah.
What's happening?
One's on my mind.
The y's are going down by 1. Is there a pattern in x? What's happening with x? They're going up by 1. So there is a pattern in x and there's a pattern in y. Well, now if we counted on that pattern, we would say that our next y value is going to be what? 0. Okay, well remember we're going to do the work. And I think you're gonna be surprised. We have to put a +1 in for x. What is +1 plus -1? 0. What's the absolute value of 0? 0. Oh. Maybe this problem's trying to make a liar out of me. It's still going down by 1. I wonder what will happen in the next one then. Okay, so what do we think it should be? According to our pattern.
-1.
-1. Okay, well, think it's going to happen? No? Let's check it out. 2 is going to go in for x. So what's 2 plus -1? 1. So we have the absolute value of 1, which is 1. Did we do something wrong, do you think?
No.
Hopefully right here you say to yourself, every time we're taking the absolute value of something, can we ever have a negative number over here? No, we can't have negative distance. So what happens in absolute value is eventually it gets to a point and it has to stop and it has to bounce back. Did you have any V looking graphs yesterday? Do you remember, were those the ones that had absolute value bars in them? And that's what should happen in an absolute value graph. We should end up with a V. I was kind of forgot to go over here and finish doing my ordered pairs. If you did the same thing, go ahead and finish with me right now. We have 5 ordered pairs. Okay, I want you to go graph those. What ends up happening?
Looks like a tilted L.
Looks like a tilted L, yeah, sure does. It looks like a tilted capital L. Or it's an incomplete V, or it's a backwards check mark, or, right? Okay. But, so here's what we do this time. We can't draw a straight line that goes through all 5 points. So what we do is we take our ruler, and because we do have some, instead this is one where, I remember I said we do a smooth curve when they don't all line up in a line. I got ahead of myself. If they look like they're making a V, which absolute value equation should do, then what we do is that point where they start to turn, our line starts there, doesn't go beyond it, so take your ruler and put a line going through those 4 points that were on the left side, on the back side of the check mark, and then take your ruler and make the rest of your V going this way. And then we put arrows at both ends because that V does continue on forever. So in reality, I could have picked some other x values that would have shown the v nicely, but I want you to see too that sometimes we can also pick x values that don't give us the complete picture. Sometimes we might get some that would only be on one part of the v, and we would think we'd have a line and not a v. So that's why for a while I like to kind of help you pick your x values. Okay, anybody get questions or concerns about this one before?
I just have
Right.
a question. Will we use the same values for x every time?
Actually, today we're going to, except for one problem in our homework, and I'm going to when we get started with the homework, I'm going to give you an idea of what we might want to do there. Okay, so again, let's just put that this is a continuous graph. We want to connect the points. So we're going to use our ruler when it looks like we have a V, and when it looks like we have a line. Okay, and now we have one of those where we had some trouble with it because we weren't using parentheses for our power. Okay, we're going to use, and don't fill in too many, because first of all, do we have it in function rule form right now, this number 3? Yeah, so here's our function rule right here. Let's move it down, and let's change it to add the opposite. And it's going to take us a couple of lines of work here, so we're just going to start, instead of filling in all our x values, we're just going to start with -2, and we're going to substitute that in for our x. So -2 is part of the function rule. -2 has to go in for x, and then we have plus that -1. So here's what we're going to do. We're going to drop down now so we can see what we actually did. What do we do first here? Do we actually multiply first, or do we do the power first? What did you learn? We know we do powers, we do exponents before we do multiplication. So we have this -2 is going to stay here, and that right there, that -2 times itself, what's that going to become? Positive 4. A -2 times a -2 is a positive 4. So what we did is we did this, became that. And now we're going to say, we're going to do the multiplying first here. -2 times 4 is? -8. And we are now finally ready to start our final column here, our y column. What's -1 plus, or -8 plus -1? -9. Okay. Don't really have room for us, do I, to write our ordered pairs there? Okay. So let's just go up above here and let's just write our ordered pair. We have -2, -9. Okay, now let's do when x is equal to -1. So we have our -2, which is part of the function rule. -1 goes in parentheses for x, plus a -1.
So what's the x value on the second one?
This is our x value right here. We're putting -1 in for x.
No, on the second one.
This is
This right here? Yep. Okay. So, I'm not sure what you're asking me, but, so what are we going to do first here? Do we have to take -1 times its
so
self? What's -1 times itself?
positive.
+1. Now we do this multiplication. -2 times 1 is -2 plus our -1. So what's our y value this time? -3. -2 plus -1, -3. So now we have ordered pair, -1, -3. Now we're going to do 0. So -2 is part of the function rule. 0 is going in for the x that gets squared. We drop down here so we can see that what we're doing is we're squaring first. Zero squared is 0. Okay, and now we say, okay, now I have -2 times 0. What is that? 0. Anything times 0 is 0. And then plus that -1. So what's our y value this time? -1. So now we have ordered pair 0, -1. Well, if you thought there was a pattern going on here, we kind of just lost it, didn't we? So we're going to keep working here. We're going to now use +1. And we'll substitute in for x and square it at our -1. We do the squaring first. So -2 times 1 squared. What's 1 squared?
1.
1. What's -2 times 1? -2. And then we have that -1 to add to it. So what's our y value this time? -3. So we have ordered pair 1, -3. And we're going to do one more when x is equal to +2. So we're going to do 5 x values for our continuous graphs today, always. -2, 2 goes in for x, it gets squared. This is just substituting into our function rule target. Then we're going to drop down to the next line and do the squaring only. 2 squared is 4. And we have -2 times 4 is -8. And -8 plus -1?
-9.
-9. Okay. So we now have 5 ordered pairs to put on our graph. Okay, go ahead and plot those ordered pairs on your coordinate plane that's been provided for you.
Look at that unfinished question. Oh my God.
Okay, something's wrong here. I'm doing something wrong.
Those are all positives. This negative 2,
-2,
-9.
-9.
So you gotta go down and
Box.
down.
Thank you. Thanks for taking care of me.
You're welcome.
Have to take it for you.
Okay, now take your ruler and notice something. If you try to do what we did in the last graph, this kind of looks like it might be an upside down V, doesn't it? Take your ruler and see, can you line a ruler up going from this point through these two on the left side?
No.
Does it line up nicely through those points?
No, it's not.
No, it doesn't. Does it on the other side?
No. Yes.
So if you tried it over on the other side and you did this point, and this point, do those line up nicely in a ruler?
No.
No. So this is not an absolute value graph. Remember I said the absolute value graphs will be our V ones. This is actually a U-shaped graph. So this is the one where we're going to do a smooth curve. So I'm going to pick another color here. And I like to do it like this because it just works best for me. You decide what's the best way for you to make that into a U. I like to start at the place where it is turning and try and make it happen that way. And it goes on, it's got arrows at the end down there because it keeps going on like that. It's an upside down U-shaped graph. That's what we should end up with.